Hello students, welcome to session number 11 in module number 2 in energy engineering, where we are going to study about the hydroelectric energy. And in this particular video I am going to explain what is runoff, what is hydrograph, what is mass curve, and what are the benefits of this hydrograph and mass curve. Okay, first we will study about runoff. So you studied about hydrologic cycle, isn't it? So where we know that most of the earth's water sources such as rivers, lakes, ocean, and some underground sources, etc., get their supplies from rains, isn't it? So while the rain water itself is evaporation from these sources, uh, okay, and the water is lost to the atmosphere as vapor from earth, which is then precipitated back in the form of rain, snow, then dew, etc. This evaporation and precipitation continues forever, and thereby a balance is maintained between these two. This process is known as hydrologic cycle, and it is represented graphically in this figure. Okay, and the hydrologic equation, you know that precipitation is equal to R plus E, where R is called as what is that? R is called as runoff, and E is called as evaporation. Okay, so we should know what is runoff. Runoff is nothing but the variety of ways by which the rainwater moves across the land. Okay, this may be by surface runoff or channel runoff. The surface runoff includes only the water that reaches the stream. Okay, then it will channelize without percolating much. That is called as channel runoff. Okay, so as the water flows, the water may seep into the ground, evaporate into the air, become stored in lakes or rivers, reservoirs, or be extracted for agriculture or any other human uses. Okay, so that is a runoff. And then there are various methods to measure this runoff. These are from rainfall records. Runoff can be measured by empirical formula. Runoff can be measured by curves and tables, or even by discharge observation methods. Okay, so empirical from rainfall record means, in this method, consistent rainfall for a sufficiently longer period is taken and recorded, and then average depth of rainfall over the catchment is determined. Then considering all the factors which affects the runoff process, a coefficient is derived. Okay, or derived, and then a equation is developed, and based on that equation, runoff can be measured by using equation like runoff is equal to rainfall into that coefficient. Okay, then second method, in empirical formula. In this method, an attempt is made to derive the direct relationship between the rainfall and subsequent runoff. For this purpose, some constants are established, which give fairly accurate result for a specified region. Okay, that constants will vary from region to region. Some important formula can be I can tell here, which is developed by different researcher. The first one is from Costlas formula. He derived the equation R is equal to P minus 4.811 T, where R stands for annual runoff in millimeter, and P stands for annual rainfall in millimeter, and T is the mean temperature in degree centigrade. And the second one, in which is developed in Maharashtra, especially in hill and plain areas. So they got the two equation. One is for plain region, and one is for Ghat region. For Ghat region, they got R is equal to 0.88 P minus 304.8, and for plain region, they got R is equal to P minus 177.8 into P divided by 2540. So these are some constants. Don't worry about that equation, and this is this you should aware of that. Then the third method is runoff curves and tables. This is also for each region has its own catchment area and rainfall characteristics. Based on that, a formulae given above and coefficients derived, they are not cannot be applied universally. So we have to record that rainfall, and we can plot a graph. Okay, based on this fact, the runoff coefficients are derived once for all. Then a graph is plotted, in which one axis represents rainfall and other represents runoff. Based on that, we can able to measure the runoff. Then discharge observation method, by actual measurement of discharge at an outlet of a drainage basin or runoff over catchment can be computed, and based on that discharge observation method, we can measure the measurement of runoff. Then we will there are some factors which is affecting on this runoff. These are rainfall pattern, how rainfall is form, or how rain will fall in particular a region. So it will vary from region to region, so that is a very important factor. Then character of catchment area, then topography of that particular land, shape and size of that catchment area, and even weather condition is also going to affect the runoff. Okay, next we will discuss about hydrograph. Okay, so this is one sketch where you can able to see a typical hydrograph. So hydrograph is defined as the graph showing a discharge, which is nothing but runoff of flowing water with respect to time for a specified time. This is very, or a specified period. So it is a graph representing the discharge of flowing water with respect to time for a specific period. Okay, so discharge graphs are known as flood or runoff graphs. The time axis may have units of hour, day, week or month. So this is one more typical kind of hydrographs. So each hydrograph have a reference to a particular river site. The time period may be of discharge may be hour, day or week. So hydrograph of stream of river will depend on the characteristics of the catchment and precipitation over the catchment. Okay, hydrograph will assess the flood flow of rivers, and hence it is essential that anticipated hydrograph could be drawn for the river for a given storm. Okay, so the discharge units may be meter cube per second or kilometer square per kilometer square centimeter per hour or a day second meter. Okay, so hydrograph indicates the power available from a stream at different times of day, week or hour. Okay, so the discharge hydrographs are also known as flood or runoff hydrographs, as I told. So this is about hydrograph. So you can able to study by drawing this hydrograph, where you can able to get peak discharge, where you can able to get peak rainfall, and what is the area, a catchment area, or then what is the storm runoff, what is the normal base flow. Okay, so storm runoff means a sudden rise. So you can able to see the color here in third sketch, isn't it? It is storm runoff. And normal runoff or base flow is the color is variation in color is shown. So by this you can able to study about the discharge. Then we will study the advantages or merits of hydrograph. This is one kind of hydrograph where you can able to see time is taken along x-axis, and discharge or rainfall is taken along y-axis in millimeter. So you can able to see from 0 to 6 hour, or time in terms of hour, 0 to 6 hour, the discharge is measured, and it is shown in terms of graphical representation. And the peak discharge you got between 1.5 hour to 2, okay, 1.5 to 2, and then sudden decrease is taken place from 2 to 6. Okay, so average or rainfall you got from during average rainfall is about 2.5 millimeter across all the time. Okay, so by drawing this graph you can able to calculate, or you can able to find rate of flow at any instant during the specific recorded period. Then you can able to calculate what is the total volume, which is nothing but the area under the hydrograph represents the volume of the water given or in a given duration in a particular specified specific recorded time. Then you can able to measure the mean annual runoff for any recorded period. You can find the maximum and minimum runoff for any selected period, and also you can able to calculate or find the duration of floods and the frequency of floods. Okay, by drawing this hydrograph. So next you should know what is unit hydrograph. This is very important one, unit hydrograph. So unit hydrograph, the peak flow represents a momentary value. Okay, so therefore the peak flow alone does give sufficient information about the runoff. It does not. Okay, it is necessary to understand the full hydrograph of flow. Then we should study about the unit hydrograph. So it is possible to predict a runoff hydrograph corresponding to an observed or hypothetical storm. The basic concept of unit hydrograph is that hydrographs of runoff from two identical storms would be the same. In practice, identical storms occur very rarely, but the rainfall generally varies in duration, amount, and aerial distribution. Okay, So this makes it is necessary to construct a typical hydrograph for a basin, which could be used as a unit of measurement of runoff. Okay, so thus a unit hydrograph may be defined as a hydrograph which represents unit runoff resulted from an intense rainfall of unit duration and specific areal distribution. Or a unit hydrograph is a hydrograph with a volume of 1 centimeter of runoff resulting from a rainfall of specified duration and a real pattern which is constructed using hydrograph data. The following steps are used for the construction of unit hydrograph. Okay, the steps: you have to choose an isolated intense rainfall of unit duration from past records. Then you have to plot the discharge hydrograph for outlet from the rainfall records. Then you have to deduct the base flow from the stream discharge hydrograph to get the hydrograph of surface runoff. Then you have to find out the volume of surface runoff and convert this into volume into a centimeter of runoff over the catchment area. Then you have to measure the ordinates of surface runoff hydrograph, and you have to divide these ordinates by obtained runoff in centimeter to get the unit hydrograph. Don't worry about this while deriving the while doing some numericals. I will explain how to find unit hydrograph. Okay, then we have some disadvantage or limitation of this unit hydrograph. These are, its use is limited to areas about 5,000 square kilometers, since a similar rainfall distribution over a large area is not possible. The odd shaped basins, particularly a long and narrow, have very uneven rainfall distribution, so therefore unit hydrograph method is not accepted for such a particular basin. And in mountain areas the aerial distribution is very uneven, and then unit hydrograph method is used because this distribution pattern remains same for storm to storm. Okay, so these are some points you should keep it in your mind about hydrograph. Next important topic is flow duration curve. So flow duration curve is nothing but it is a useful graphical representation of the runoff for a given period. It is a useful. So flow duration curve is another useful form of form to represent runoff data for the given time or given period. This curve is plotted between flow available during a period versus the fraction of time. Okay, flow duration available and a fraction of time. Okay, in percentage, time in percentage. Then if the magnitude on the ordinate is the potential power contained in the stream flow, then the curve is known as flow power duration curve. The curve is a useful, it is very useful tool to analyze the development of water power. Okay, so runoff data on the ordinate against the corresponding percentage time on the abscissa represent flow duration curve. The flow may be expressed in meter cube per second or meter cube per week or any other convenient time. When the available head of water is known, then the total energy can be computed. Okay, so these are you can able to draw the flow duration curve. The flow duration curve is drawn with the help of a hydrograph from the available runoff data, and here it is necessary to find out the length of the time duration which certain flows are available, okay, length of the time duration which certain flow are available. This information either from runoff data or from hydrograph you can able to get or you can tabulate it. Now the flow duration curve taking 100% time on x-axis and runoff on y-axis can be drawn, okay. So some uses or merits of this flow duration curve you can able to list. The uses like a flow duration curve allows the evaluation of low level flows. It is highly useful in the planning and designing of water resource projects. Uh, the flow duration curve also finds use in design of drainage system and in flood control studies. And this curve plotted on a long log paper provides a qualitative description of the runoff variability in the stream, okay. These are some advantages. Then we will discuss on mass curve. So this is about mass curve where you can able to draw the cumulative discharge versus time, okay. So mass curve is the graph of cumulative values of water quantity or runoff against time. A mass curve is an integral curve of runoff, uh, integral curve of the hydrograph which express the area under the hydrograph from one time to another, okay. So it is convenient to determine the storage requirement that is needed to produce certain dependable flow from the fluctuating discharge for a discharge of a river by reservoir. So it is convenient method, okay. Then the masker will always have a positive shape but of a greater or less degree depending upon the variation in the quantity of inflow water available, okay. And mathematically the mass curve can be given by the relation V is equal to integration of T1 to T2 QT into dt, where V stands for volume, okay, of runoff, QT stands for discharge, total discharge, and you have to, if you integrate uh, the initial time to final time, you can able to get volume, okay. So this is about mass curve. So in this particular video we studied about what is runoff, what is hydrograph, what is unit of hydrograph, and what is flow duration curve, and finally we studied what is mass curve. This is very important topic, or very important topic in order to construct or in order to study about hydroelectric power generation.